manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
Episode 18 of the MTD Podcast. Glad you could be with us today to listen to this. I'm joined by Mr. Gio Albanese, and we're going to be talking today about vertical machining centres and some of the pitfalls that you may come across or things you might want to avoid when you're purchasing one. Also, some facts and figures from the industry about this style of machine and how things have changed over recent years. Gio, how are you doing?
I'm very well, thank you. Paul, how about yourself?
Yeah, right? Good, thanks. You've got a lot of experience with VMCs. You must have used a few in your time.
Yeah, well, I started off on a manual knee mill with the indexing tables. I don't know if you can remember them, Paul, with the holes all around. You had to calculate which pin to put it in to turn the table, how many degrees. It was quite complicated. And then
easy to make an error.
Absolutely. I mean, it was...
That was when there was real... I'm not saying there's not skill in it today, but that was when you really had to... spend 3 or 4 years in your apprenticeship learning the ins and outs of not only, milling, turning, grinding and all of those different disciplines, didn't you? Because things like that were massive factors.
Absolutely. I think that's when you kind of used your maths and stuff like that to use trigonometry and Pythagoras to work out angles and stuff like that. It was crazy, really. I think that, from there you progress to the CNC, but you get all your learning from there. And I still think it's extremely important that the younger generation learn on a knee mill, because you can even tilt the head, can't you, Paul? So you can still do fifth axis work, but you've got to do all your calculations, but you actually get to feel the cutting tool cutting the material, so you get to have a feel for your
much vibration, torque and all the rest of it. You can get that.
It's really important.
Your experience of vertical machining centres. What we're going to talk about really today is the types of machines that are available, things that people should consider. Although it seems to still be quite a simple machine and a simple purchase, I do still feel that people jump into buying a VMC very quickly, maybe without considering a lot of the options. I mean, I was looking at, before we've done this, or before we looked at this podcast, about how many vertical machining centres there are out in the market. And in fact, I got to 120 suppliers before I stopped. And that is really how much choice there is in machines. Wow. And with the machine, the first VMC was sort of developed in the mid-80s. You can see from there being only one or two around then to how many there is these days. Things have moved on a lot. In your opinion, what do you think are the main points that people should consider? And maybe what are the pitfalls? What don't they consider?
There's so many points, aren't there, Paul? I mean, for example, let me kind of use an analogy. If you were to have a Rolls Royce, it'd be a beautiful ride. But if you were to tow a boat and go off-road, it's not the right car for you. And I think it's exactly the same with a machining centre. I think that the main considerations... One of the main considerations has got to be your budget, surely, because you especially if you're a new company and you're starting up, you have got a set budget, but then you've got to look at the components that you're manufacturing, the size of components, the materials, in what volumes you're manufacturing them components in, and how accurate do you need to make them components, and the longevity of the machine. That you probably only get to feel or learn about the longevity after you've actually purchased it, to be fair.
And here's the thing, you talk about budget, right? And this is one thing that never ceases to amaze me. When I sold VMCs, machining centres, back in the early 2000s, a standard vertical machining centre, let's take kind of a 600 by 375 or 400 machine, might have been 50, 55, 60K from memory. Nowadays, there are machines of that size that are far less money than that. So it just shows that people are trying to not only develop new machines, but keep the costs down, because they realise how important that budget factor is. But if you buy a cheap machine, is it going to last as long?
Yeah, absolutely. If it's for the right application, I think that again, if you're cutting aluminium and soft materials, if you're not using it that frequently, if you're using it to do one-offs, two-offs, it's not running, or you're not buying it to run 24/7 and double shifting. It should,
Well, I think budget is a big part of it. And it is a place to start, but some might argue it's a place to finish, because really, should you firstly look at what, like you've correctly said, the application that you're doing, what you need it for, but secondly, really, how the machine is going to last you. Because if it lasts just 2 years and you have to throw it in the skip and buy another one, that defeats the budget argument, doesn't it? You've got to look at how long it's going to last you, and therein lies how the machine's made. So it's about the base of the machine, the casting of the machine. Does it have a box guideway construction? Is it running on linear rails? How big are those rails? How big are the ball screws? How are they supported? The spindles, that's an expensive element as well. Are they belt driven? Are they direct drive? All of these things go together to give you better machining results, but also a machine that will last longer, but it's likely to come with a bigger price tag.
Yeah, absolutely. I think that with the longevity of the machine, again, I think it's difficult because, say, for example, you're a startup company, you're guesstimating what work's going to come through the door. You don't really know, do you? So, you could be planning to take on aluminium work, but then you get hard materials.
Example. Let's say you're a general subcontractor, because that is the majority of engineering companies. Where do they start? What do they think if one day, especially with the way the market, you're right, you'll be machining aluminium one day, and then you'll have your customer come in with a piece of tool steel the next and say, I want you to make this component. How do you go about speccing out a machine that's going to try and cover all of those bases?
There's an argument to say that you need to future-proof yourself and go for a machine that is rigid, that is solid, that has got box guideways, that will last the test of time. However, that will come at a greater cost. So it is a catch-22 scenario, really. I think that if you've got the budget, then I would probably, recommend, and I might not be correct, but I'd probably recommend go for the best that you can afford. If that's the case, because then you can take on more work, and you know that your machine tool will deal with that work. However, if you have got a smaller budget, there's an argument to say maybe go second hand. I don't know, Paul. I know I
always think the argument of the service. How often have you had to call out an engineer for a machine over a period of a year if you're running 8-10 hours a day? Because when a machine is down, that is so costly, isn't it? You could potentially lose a customer. So the reliability is key, but coming into the reliability does come down to the build of the machine. It does come down to not only the hardware, the software as well, the experience of the machine tool builder to make that machine and continually make it successfully. You mentioned the box guideway argument. People say, yeah, we should have box guideways on machines. But over a period, I remember again, and I go back to when I was selling machines, I used to sell VMCs and 80% of them had box guideways. It was like, we must have a box guideway machine. Well, why is that? Well, because it's going to dampen out the vibration. I can take heavier cuts. It's going to last longer. But then over the last decade or so, the mentality seems to have changed, where people are going, well, all right, if you still want a box, have it in the Z-axis, but don't have it in the X and Y, because you can still then benefit from having the speed. And also, if there is an issue, you can replace linear rails, which you can't really do with box. You can re-scrape beds, but it's a wholly lengthy and expensive thing to have to do, isn't it?
Yeah, I think that's a really good point. I think that in regards to linear and box guideways, I think over the years, cutting strategies have changed from the cutting tool providers. So, I can remember, through my own experience, Paul, and you probably remember as well, when we were apprentices, we used to use rippers. Can you remember the high-speed steel rippers? The forces that go through them kind of tools were really excessive. But now, we're all using carbide cutting tools, and it's more, and we used to take deep cuts, slower feeds and speeds, but now it's higher feeds and speeds and lighter cuts, and apparently the material removal is a lot greater this way, but you're not putting the strains on your spindle, so you don't need to have the box guideways anymore, and you're actually reducing the cost of your machine tool. But nevertheless, if you go into the oil and gas industry where you're cutting some of the really hard materials, I don't think that's going to be man enough, a linear guideway machine for that type of application. So, I think that when considering a VMC, you really need to discuss these aspects and make sure that, write down what you're looking to do and take it to your provider and see what he says.
And I think there is also, when you start talking about the build of the machine, also we mentioned the spindles. You've got BT30, BT40, BT50, HSK. You're looking at spindles here that are ideal for different applications and different material types, and give you different results. BT30 is coming on now,
BB.
And BBT40 and BBT50. All of these different tool mounts are are improving as well. So some people are saying, well, actually, you should go for a BT50 because you've got plenty of stability, but we can still get you some speed. And then you've got the BT30 argument where they're saying, well, you've got the speed here, but we can now provide you with the stability and the power as well. So it does make making those decisions quite tough.
I mean, if I was starting up my own business, it is a minefield out there, isn't there? You know, where do you start? Who do you trust? And I think that's a big thing. You need to kind of go out there and do your own investigations and really start forming relationships with the providers and asking them all these questions. I think that one good thing is, Paul, now that a lot of the OEM companies now are providing turnkey packages where you'll take them certain components and they'll machine them for you, and they'll do time studies on them for you as well. I think that you should make the most of this. If people are offering that, it's a really good way of...
I think that's a massive point, because I'm not going to lay blame at the feet of the salesman in this industry, because there are some great sales guys out there, and they're needed. They're needed to go out and sell the virtues of the products that they do. But what I always used to find when I was selling machines is it was very difficult to learn everything that suits a specific application, and you might get it wrong. So a few heads is definitely better than one, and that offering from machine tool companies to be able to take parts, demonstrate that they can do the best job for you is definitely an option. Always fine with that BT50. They're much bigger machines as well, aren't they? But do you ever get a BT50 on a smaller machine? Do you need a BT50 on a smaller machine?
No.
It's difficult as well. And we then look at machines that have got one-piece castings, two-piece castings. The C-frame construction. Where is it just the X and the Y that's moving and the Z that's fixed, or the head that's fixed? Because there's different configurations as well, which offer different rigidity, don't they, and different results.
Yeah, I think that predominantly you do get the table that moves, but you do get where the head moves along the table. It's usually when you've got a longer bed machine, isn't it? So if you've got a heavy component that's on there, the machine bed hasn't got to move with a really heavy component on it. Your Z-axis effectively will be moving around and doing all your cutting, so that
because if you've got a heavy bolster that you're moving around
you
on the table,
want to do that.
The wear on the machine is, and it's going to be slow as well, getting from point to point.
Absolutely,
if you're rapid in.
But I think I'd say that the majority is, the table moves. But when you come into big machines, then the head moves.
And the VMCs over time, they've gone from just being 500, 600X to a meter X to 1.5 meter X to 2 meter X. Now we see 3 and even 4 meter X axis machines that are becoming more popular, the bigger ones, because they're not just there to do parts that size, they're there to give you the flexibility to load more components on a table, aren't they?
Absolutely, Paul. And I think that's leads me on to another good point, and a very good point, that they are very versatile. I mean, we talk about, you need to buy a fifth axis. We need to buy a fifth axis all the time. And to a certain degree, you do, with automation, I believe. However, the versatility you can get from a 3-axis machine, you can have it 4th axis prepped, 5th axis prepped. So you can still do your 4th and 5th axis work on there. But as a subcontractor, like we mentioned, you don't know what's going to be coming through the door one day to the next. But it also gives you the option to do 2D work, but even 3D work with the CAD-CAM packages and the bullnose contouring that we discussed earlier, Paul. So pretty much you can do any kind of prismatic parts that you need, albeit you might need to do it in an extra operation. But if you're a startup company, you can do pretty much any prismatic part. And like you say, if you've got a large bed machine and you've got smaller components, with the right work holding, you can present a lot of components to the spindle and utilise the internal envelope of that machine.
Although it's probably going to cost you a bit more money, and you're going to need a bit more floor space. Let's do something interesting. Let's look at the where you might get tripped up when you're buying a VMC, because this is this will be what people want to hear. What are the things that often go overlooked? I've got a few I've made a note of, and I think one of the ones I always used to find was the swarf extraction. It seems very, very simple, but so often I might sell a machine, I don't need a swarf conveyor, and then you go and see the guy a couple of weeks later, and there he is, doors open, shoveling out the swarf, and he says, "Really, you didn't want to spend 1,800 quid on a swarf conveyor? However, how many man hours are you going to lose over the course of 2 years, 3 years, by getting in there and shoveling it all out, not to mention the health and safety risks that we all encounter these days. That was one of the things for me. I always think that if you're making swarf, you've got to get it out of the machine in the most effective and efficient manner so you can keep that spindle going. That's one thing for me I would also pick up on. Another simple one for me, and I know you're going to come on to ones that are probably bit more technologically involved, but VisiPort windows and visibility.
Yeah, I like them. They're coming back.
They are. I mean, how important is it to be? I know people will say, well, actually, my CAD/CAM system is verifying my program, so I don't need to see what's happening in the machine. I don't buy that one.
I don't either.
I think you need to be able to see what's happening in your machine. You want that element of security, and I think those VisiPort windows offer a tremendous solution. Again, they cost money, but if you get them at point of sale, they are, possibly going to benefit you.
I think from an educational perspective as well, I think they're great. If you're trying to train an apprentice up to run your VMC, but they can't see what's going on, how do they learn? They can't visualize something that they can't see. So I think from that perspective, I think they're great, and they're definitely making a comeback. We're seeing them more and more as we go around. And now with
I could never sell them. When I was selling machines, no one ever wanted one. They were on the list, and it was like, you should have a VisiPort window. And they're like, well, how much is it? And I can't remember the prices now, but they used to go, no, I don't need that. And you'd go, okay, well, if it's going to stop me getting the order, I won't bring it up again. But you should.
But back in the day, they used to take the door interlocks out, didn't they? And that's now kind of an health and safety must, really.
That's why I lost my scalp. That's where my hair went.
So, like, when setting the machines now, they've got to do it to a certain degree with the doors closed in some scenarios. So that VisiPort then comes into play even more. And another consideration that has come into play recently is air filtration as well, Paul. I know that legislations are going to be changing this year, I believe, or so I've been informed. Now, to have your machine already with your air filtration on there is going to be a necessity now, not a luxury item, because what they're saying is if there's still mist in the machine, once the cycle is finished, you've got to put a delay on before you can open the machine door, so it gives time for the mist to evaporate or go away. So you'll be adding seconds to each cycle. So it is going to be something.
Wow, how good is this for filtration supplies?
It's massive, isn't it? Really,
yeah.
It's absolutely huge.
Good grief! I wonder how many machines currently at the moment are using mist extraction and filtration solutions.
I don't know, but that's something that I think we should do another survey on that, or in the future, an MTD survey on that. And I think that it is. Do
people know this as well? I mean, I know I have heard it in passing that you mentioned to me, but I've not sort of computed it to the.
I spoke to one of our clients. I won't mention any names, but he said that he had an health and safety guy go in to see him, and he said that there was a new machine tool that he'd purchased from a well-known company, and it didn't come with the air filtration. And he said it's fine, but he says if any of your employees get lung cancer or kind of try to sue you because they've been breathing in that air, as the MD of the company, you will be liable.
Yeah.
So basically what he's saying is you've got to go and get air filtration put on that machine.
Wow. Okay, that is massive.
So that's been massive. A bit controversial there.
No, that's fine. Amount of tools. I come back to this one so often. How many times do you 20 station tool change at 22, 24, is it enough? 30, some VMCs these days are offering 40, 48 tools. How much of an advantage is that? I think it's massive.
I think it's massive for one of the reasons I think it's massive is when I was working in the aerospace industry, I used to work on a cell called Strange and Alien. So I used to do all the prototype work, and then once I'd proven it out, I'd put it onto a production cell. And what we did on the production cell and how we set up the production cell was we grouped components or family of components that used the same tooling. So what we'd do, we'd load up the carousel up with that tooling, keep the tooling in the carousel all the time, and just load up all the programs for all the different family of parts that used the same tooling. So basically then all we had to do when we were setting up a part was to put the work holding on, set the datum, call up the program and press go. We'd keep the tools to a preset length. We'd always use brand new tooling, or if it was a roughing tool, we'd make sure we'd reset that into the figures and the offsets. But, if you think of that, it used to save so much setup time, if you can imagine. So each machine would run certain parts all the time, and it worked really, really well for us. If you only had, 24 tools. You couldn't do that.
You can't, no, exactly. And I think that I've seen recently a few machining centres offering 48 tools, and I think, hang on, they've stolen a bit of a march there, because that will win you the order, or should win you orders in certain instances, because you cannot ever have enough tools. I can guarantee you buy a machine with 24 tools, at some point you're going to go, oh, I wish, I've got the 25th one, and so
there's certain tools you'll keep in that carousel all the time. You never have to keep taking them in, putting them out, because setup time now, we keep talking about keep that spindle turning. I don't know how many companies adopt this kind of strategy when doing parts. I mean, in the aerospace industry, it was medium volume, but it used to repeat every single month. So to be able to have that carousel where them tools were constantly in there, the setup time that saved was massive.
The average efficiency of a VMC is still less than 40% if you use it in a kind of traditional way.
Yeah, and that's a way of really increasing that efficiency.
Totally. I mean, it seems criminal, doesn't it, to think that you can have a machine that you're only getting 40% of its possible value out of. There are ways of enhancing that, which we've touched on, the automation side of things, but it's still an unbelievably low figure. We
really kind of dug deep into that in my previous role when I was selling. Doug. Sorry, I can't get my words out, but we really analysed that, Paul, when I was selling work holding, and we used to sell the dual station vices, and when we were doing op 1 and op 2. So you'd actually load up op 1 and op 2, so you'd flick it over. The time savings that had was absolutely huge in regard to keeping the spindle turning. You still see a lot of companies on 3-axis machines where they'll do op 1 and they'll run all op 1, then they'll do op 2 and run all. So I mean, to be able to do it all in one. So effectively, what you're doing, you're getting a complete part off the machine each cycle.
Yeah. Efficiency improvements. And some of the other things to look out for. I wonder how many people have been tripped up with this one. Buying a machine with a control that maybe doesn't necessarily have all the features and the functions turned on that you thought it might. Yeah. Because these features cost money, these options cost money, and sometimes companies will sell a basic machine without some of those functions being turned on. You might get the machine and you might think, I can't do this. You have to phone up, I don't know, Fanuc, Siemens, whoever, to get to buy these modules or options. So it's something to make sure that the control always has what you need on it.
That's an absolutely excellent point, Paul. And again, I'll refer back to my experience when I was selling rotary tables. There was so many companies that I went into where a good example I can give you was someone wanted to get into 5th-axis machining. They had 3-axis machines. They wanted to get into 5th-axis machines. Before they took the plunge and bought their first 5th-axis machine, they wanted their operators and programmers to become familiar with programming in 5th-axis. So they wanted to put a 5th-axis rotary table onto their 3-axis machine. But unfortunately, the machine wasn't prepped for it. So it cost them a lot of money to get it prepped. I know that 5th-axis is slightly different to 4th-axis, but really when you're buying a machine, you should always, at the very, very least, get your machine 4th-axis prepped at the time of purchase.
I've done it, mate. People must listen to this sometimes and think, gee whiz, he sold some many people short on many occasions. That's not the case. But one thing I did do once, I remember selling a VMC and a 4th-axis unit, but the machine didn't have an interface on it. So because the way the company I was working for at the time, we were very much in control of the whole order. You would sell these things, and then the guy would say, well, we've got my 4th-axis here, but apparently the machine isn't interfaced to go with it. Oh, is it not? No, I used to go, I didn't include an interface, but it can be so expensive after the occasion to actually interface a machine. So get it done at point of order.
Absolutely. I think get as much as you possibly can, because you don't know what's around the corner.
You don't. So they would be certainly on my thing. Oh, there would be one last one. Spindle warranty. Spindles are obviously an integral part of the machine. They're an expensive part of a machine tool as well. And warranties on spindles can sometimes be either sold in hours or they can be sold in years. And it's always worth just checking whether is your spindle warranty 2 years, but actually only a year's worth of hours if you run 2 shifts, or is it 2 years unlimited? That's always a consideration to make, because if you have to replace a spindle. But bearing in mind in all these points, I have to say that vertical machining centres over the last couple of decades, or certainly over the last decade, from wherever they're manufactured around the world, it's very difficult to criticise the quality of products these days. Having it been recently in the Far East at a machine tool show, looking at, I said 120 suppliers of machines that you'd never, names that you just think, where has that come from? But they're all now built to a certain quality and to a certain standard, and they will last, in a lot of cases, the test of time. So you can't do a lot wrong when buying a VMC, but there's hopefully a few points that will be worth considering along the way. We'll be back doing the same again next week, but next time on Turning Centres. So thanks a lot, Gio.
Thanks, Paul.
See you next week.